I'll be starting shortly. Welcome to Microcontrollers with kingernorth. This is episode 22, Encoder Inputs with CircuitPython and Arduino. Welcome everybody. Wow, let us have a look at what we're doing today. So today we're going to be looking at encoder inputs. So there's lots of different encoders out there, so we're going to talk about a little bit about encoders to start with, but let me show you some of the items we're going to be using today. Of course, we have our familiar Arduino Uno here, and it is connected to an encoder, and we will be talking about that. There's also a couple of LEDs here, and we'll be talking about how that works with it too, so we can show how the encoder works. Also have here, as I have the Feather M4 Express. This is the same one we've been using for most of these shows, so we've been using these two items. And we're going to be talking about what's going on for these, and we're going to be looking at how we utilize that. I also have here a selection of other encoders, and this is what I want to point out to you. Good morning, Walter. So these other encoders here, this is the encoder right here, and I'll be taking a closer look at this one. This is the one we're going to be using on our boards today. This is a nice little package, and I'm going to talk about that. But what I also want to look at is this is an encoder. This is a rotary encoder. It gives me inputs. It's got 3-wire connection on the bottom there. But it is very, very hard to turn. It's very stiff on the shaft. So I don't tend to use this one very often, but it is there, and it is another encoder that I can use when I want to use one. I have a little tiny encoder here. This is a little tiny one. Let me, if I can hang on to it. This is a little tiny one. Now this one happens to be identical to what is used in my Digitrax throttles on my train layout. And every once in a while, my older throttles, I've had to replace one or two of these that have been broken, and I've replaced a couple for other people. And these are just a simple 3-pin connection on the bottom, and it's a very lightweight encoder. Very small shaft, very small package, but it is an encoder just the same. So this works as well. The next one I have up here is more of a commercial, and it's a little bit heavier duty, still used a lot in the hobby industry. But what I have here is I have an encoder wheel, and as you can see, there's all kinds of slots in it. And the slots allow light to come through. And then you use something like this. This is an infrared emitter and detector in a package. Now you could use it without the package. The advantage with this is it is very precision made, that it has a very slight slit in the plastic to allow the light to come across. So it's a very narrow beam of light. And basically what happens here is this disc is mounted on a shaft, and it is put in between here, in between this, and then as it turns, hard to see the light there, but as it turns, the little beam of light goes from the source to from the emitter to the detector, and is red. So as it goes through, it gets seen and blocked, seen and blocked. So this is a single channel encoder. So this only has one output pin or input pin into our PLC or into our boards, our microcontroller, but we could use it for counting things very quickly. So we could use it for RPM calculations and things like that. So that's something that can be used. The other thing I have here is this great big one. So let me just slide these two out of the way for the moment. Let me show you a little bit more about what a commercial one looks like. These are commercial encoders. So I'm going to just move that out of the way. This is a full-blown industrial encoder. This is a very sealed package. This has been used out in the field before. It's not perfectly clean. This one here counts 500 counts for every revolution of this shaft. And it is very smooth to the touch to move. It's very, very fine. It's got a high quality bearing in here, permanently sealed bearing, so it's lubricated. It has a large, what they refer to as an Amphenol, not just the company that makes it, is a multi-pin plug. And this has multiple channels on it. This one actually does an A and a B channel, but it also does what they call a Z channel, and I'll talk about that when I talk about how the encoder works. I've taken the screws out of here to show you a little bit of the inside. Inside of the industrial versions, there's a whole circuit board. This circuit board is very, very detailed, but there's some main components in here, and I want to point that out. In here, that's our emitter source. That's nothing more than an infrared LED, and that's what's used to send the signal. Now, the detector is in this little chip here, this little long chip, tiny chip here, and it has multiple sensors along it. So it's not just one, it actually has up to 6 on here, because there's actually 6 channels on this encoder. There's an A+, an A-, a B+, a B-, a Z+, and a Z-. And then there's a bunch of trim pots here to do some fine adjustments on the amplifier circuits, and a whole bunch of wires going out that we can tap into. Now this one takes 24 volts coming in to run the circuit board, and then everything else is done on the board. What's hard to see is where this emitter is in here. There's a dark piece of material here, and on that is a bunch of slits with the light passes through. And in behind it, when I turn this shaft, there's actually a disc with all kinds of holes in it, and I'll kind of represent that with one of my drawings here so you can see it. And the light passes through and hits the sensors, but it's seen and blocked, just like the slit was on that big plastic wheel, except these are very tiny. And on the outer rings, which are channels A and B, there are 500 holes per revolution. Channel Z, there's 1 hole per revolution. So it can actually count how many full turns this is made. So, and it's also referred to sometimes as the reset. So what it does, it lets you know that it's gone 360 degrees and it resets. You can actually reset it. So you can use that for applications on a PLC. So that's what an industrial one looks like. A lot heavier, a lot more electronics in it, a lot more detailed, and high precision. This is also a lot more money than those other ones were. This is one that came out of a job years ago. We pulled it out because we actually replaced it with a new item, and this one just didn't get used anymore, so this was surplus. So let's get to what we're going to work with today. For today's episode, we're going to start by using this Arduino, and this is in fact, I'll turn it this way so we can zoom in on it shortly. But what's hard to see is I have this mounted because I have it plugged in. It has a 90-degree connector on it. This is your encoder that we're using. So let me just put that in my hand so it can focus in on it. That's the encoder we're using. And on here, it's got some very simple, in fact, let's get it turned around the right way. Can we get it without the light shining? There, that's not bad. So we start out, we have what they refer to as clock, DT, switch, plus, and ground. Basically what this is we have a ground pin, we have a positive pin, so we supply it with either 5 volts or 3 volts. It'll work with either, it doesn't really matter. There's nothing electrical, there's no optical sensors in here, and I'll talk about that with the different styles of encoders. But what we have in here is I have a switch because the center, you can actually barely push that down, and you might see that turning, that pushing, ever so slight. And when it does, it actually closes that contact to the switch. And then the clock and the DT are actually your A and B pins. So those are your 2 pins where we're getting the encoder pulses. So that's what we're using today, and I just have it already attached to the board. So let's talk about what's in an encoder. So let me go to my main page here. And in fact, I think I can zoom this in one more. Let's try doing that. Oh, look at that. We got a nice big image of it now. So we can see on here, this is the encoder. I have mounted a knob on it just to make it easier to turn while it's in the base. I've wired it up. I'll talk about the wiring shortly. I got a couple leads going off to a red and a green LED, and then the board itself with power coming from the board out to this board out here. So let's have a look at what we're using today. So let's have a closer look at, starting with what's an encoder. So this is a big deal here. This is an encoder. An encoder uses nothing more than a disk, and it can use a light source. And it'll go through and it'll pick up on a sensor, and then there'll be something to change it from some sort of a sine wave, typically, to a square wave to give you pulses. Nice clean pulses out. Now this is a photo rotary encoder. In other words, it uses an infrared light source typically, and it uses light. to read through the discs. Now this is more what a commercial one would look like. If it was that other one that I showed you, the big commercial one, there would be a second set of slots here that would be offset from the first set. And there would be it would use the same LED source, and it would use a second sensor to pick that up. And for the Z, for the single mark, there would be one hole in a circle here, and it would pick up on a third sensor, and so on. And that's what basically happens. These are not typical in your hobby, and it's not the one we're using today. What we're doing is we're using a mechanical version of this. Basically what there is there's a bunch of electrical strips that are on here, and as we turn it, we're going to make and break contacts similar to a potentiometer. So a potentiometer, we change the resistance as we turn it from its minimum to maximum position. An encoder turns the full 360 degrees, and what it does, it makes and breaks a bunch of small contacts mechanically as it moves around. They also make this in a magnetic version where there's a number of magnets, usually man-made disc that has north and south polarities along the edge. And then what we use is we use a Hall effect sensor on it, and that affects the magnetism, so we can get pulses from that because we can tell whether the north pole is there or the south pole, and as they go by, we get that pulsing effect. So that's another method of doing it. And you can have single channel, multi-channel for magnetic. There's also a capacitive type as well. Works with a semiconductor material. But for the most part, the ones that you're going to buy and we're going to be using today are a mechanical wiper. So as it goes by, it just makes and breaks contacts. So let's have a look at what kind of signal we get out of it. So this is what we see when we in here. We have these mechanical contacts going around, and they're all going to be connected to either ground or power, depending on how it's set up. And then what we have is we have output A and output B. And what happens here is we get this nice square wave. So as soon as we make contact with the surface, we get a positive pulse on it. We go across, and as it's turning, halfway through its cycle, B will then make contact. So these are actually 90 degrees. These are all 90 degrees out of phase with each other. So we make, if we're going to from left to right, we would see A first, then B would go true, then A would go false, then B would go false. And by doing that, if we look at the order of that application, if we look at ones and zeros, one being channel A, or the first number being channel A, the second number being channel 0, you could say this is, when we start, it's 0, 0. Then what we see is 1, 0, then we see 1, 1, then 0, 1, and then we go back to 0, 0, and then we go back to 1, 0, and 1, 1, and the cycle repeats. So there's 4. So you'll sometimes hear the term quadrant encoder in there, and that just means it's doing the 4 pulses. It's seeing where they're both false, A is true, B is false, A and B are both true, and then A is false, B is true. Now, if you move the other direction, you go counterclockwise, for instance, we would see the B first and then the A. So by knowing the order that our pulses are coming in at, we can tell whether that encoder is being turned clockwise or counterclockwise. And that's what we do here. So now we're going to have a look at we're going to move this way through the diagrams. We're going to look at our circuit that we're using today. Down here on the right hand side, this board with the resistors on it, this is what's built into that board. I put it onto a separate little breadboard here to show you because I don't have a diagram of that exact encoder that I'm using, but it has 2 resistors on the back of it. So those resistors are already built in on that board. And basically what's happening here is here's my 5 leads that come off of it. So those are my 5 pins that are on that board. And I have a common, a power, a switch connection. This is connected to this side with only 2 pins here for the switch. It's the switch and ground. And then on this side here, I have my A and B channels coming off of here. And again, what I'm seeing from there, there's the center wiper, which is connected to ground. And what we have is we have power to the outside resistors. So if we're not making, this is high. And if we are shorting, it is going to ground. So we see pulses happening. So it gets that reference voltage coming in on 2 of the input pins. And I just happen to have them connected to 4, 5, and 6. 4 for the switch, 5 and 6 for pins A and B. And then up here I have two LEDs. I have them connected to 10 and 11 with resistors on them. And what we're going to do with those eventually, when we're finished writing our program, we're actually going to be able to fade the LEDs on and off based on our encoder values, what we've done with our encoder. So we're actually going to have the encoder driving these two LEDs. And we're going to see how that works. Now, for the Arduino, you're going to notice we have these little tilde symbols beside the 10 and 11, or they'll be marked some other way, or you may have to look at the spec sheet if you're not using an Arduino version of the Uno. And you're looking for pins that have pulse width modulation outputs on them. So that's what we're actually sending to here, to the LEDs. We're going to be using pulse width modulation to output. These can be any inputs. There are some things in the program we can do to speed it up, and I'll talk about that when we review the program, when we create it. So there's a few choices on where to bring A and B into this. All right, so why don't I turn that off, and why don't we start programming? Let's get going with our programming now. So here we are. We're starting with our typical blank program to start with. So the first thing I want to do is I want to do a file save as. So I'm going to do that. So I'm going to go File, and I'm going to go Save As, and I'm going to create a new file. So let's create this under today's listings here for my electronics shows. And we're all the way down to episode 22, Encoders. I already have the program in here built, which is what I'm basically going to copy. But I'm going to create a new I don't have to create a new file. I just have to create, it'll create the folder. So I'm going to change the name here to Encoder Test 1. And I'm going to save that. And up here, it made it Encoder Test 1. So now we have our file that we're going to be working with. First thing we want to do, let's put our name in at the top of what we're doing. So this is a comment. So this is Encoder Test 1 by me. So just my basic information that's up here. We always want to make sure we have some of that information at the top. My original one, I just called it Base Encoder. Base Encoder Arduino, just because this is the basics for our encoder programming. We can get a lot more detailed if we want to. To make life easy, and this is something you should try and do when you're doing these things, make things easy on yourself at first. So we're going to include any required helper files. And we are going to do that today by including, there we go. So we're going to include, in this case, a file called Encoder. Now this is one that you can look up when you're doing your library search. I'll show you that in a second here. So that's going to be the file that we're going to be using. If you're not sure where to get this from, this particular one is called Encoder. There are many encoder helper files out there. This was just one of the simpler ones I found. So I thought I would use that for today's example. If you go up here under Sketch, you go to Include Library, and all you have to do is click on Manage Libraries. And it's going to pull up a window similar to this. And then up in here, all I do is click into this box, and I click Encoder, and I just type in the word Encoder. And when I do, I can see I'm going to get all kinds of stuff here. This is for an absolute contact encoder over I2C or digital pins. Well, we're not doing an absolute encoder, so let's skip that one. There's another one by Ace Button, it's called. That's an encoder. There's an analog I/O version. There's lots of different versions down here. And what I did is I just used this one here by Paul Stroffingen, I think it's how you pronounce it. And this is just a counts quadrant pulses from rotary and linear position encoders. And this is about as simple gets. There are all kinds of them, as you can see down here. There's lots of people who have written helper files for the encoder. You can load in 2 or 3 of these and give them a try and see which ones you like. But this is a very basic one, and that's why I want to use it for today's examples. So I've already installed this, so I'm not going to hit install. and I'm just going to close that window. But that's where you find it. You just look through there, and a lot of times you can find the helper files you're looking for. Now, what we're going to do down here is the first thing we have to do is we have to create our encoder objects. Anytime we're going to do an include file, we're adding an external device, we probably need to create an object for it. So create the encoder object. Now I will be copying some of the code as we get into the other part, but right now I'm going to be able to type things in. This is pretty straightforward. Like I said, this is a simple one. So this is just encoder, and they called it my encoder, just to keep it simple. And then what you do is you attach it, you tell it which pins you have it attached to. So in my case, they're attached to pins 5 and 6 on my board. So that's, I think I actually I single space there, okay. So I'm actually connected to pins 5 and 6. Now, you have a choice of pins here. These are just standard inputs, so they'll work fine. Something on the Arduino boards, like this one here, is pins 2 and 3 are referred to as interrupts. This helper file will allow you to use interrupts, which will give you faster reaction when you're turning the knob. So if you have a big program, you don't want to miss when you're turning the knob. And think about it as turning the volume control on your car radio. Usually a lot of your cars now, they have volume controls, and you turn the dial and it turns forever. And that's because it's an encoder. So you could do something very similar with this. You can do it to dim and brighten lights by turning a knob and have multiple turns to make it happen. There's no stops at the end of it. So if you connect it to pins 1 and 2, or pins 2 and 3, you can actually use the interrupts that are built into this board. But I'm just using 5 and 6 just to show you that it works on plain inputs as well. There are other boards like the Mega and there's Pro Minis, and that will have different pins available for interrupts. And on some cases, they have multiple interrupts, which would allow you to connect up multiple encoders to interrupt pins. That's more advanced than what we're covering in today's. We're just looking for a simple encoder. We don't need all those fancy tools yet. So let's continue on with what we're doing. So we've created our object. So now I'm going to go in here and I'm going to create a couple of stuff, getting myself ready, but I'm going to create any required pin assignments. So when I do this, I have on here is I have a switch and I have 2 LEDs. So I'm going to need pins for each of those. So let me go ahead and create those now. So I'm going to create a pin for the LED green pin. And that happens to be connected to pin 11 on this board. I am then going to create my LED red pin. And that is connected to pin 10. And then I'm also going to create my switch. So I'm going to create a switch pin. And I'm going to connect that to pin 4. So that's where everything happens to be connected. We will need to do something, so I'm going to go ahead and put in the title here. We're going to have to create any required variables. And we will need a couple of variables in here. So one of the things we're going to do is right off the bat, and this is one that's suggested in the helper file when you load in the example that's written for encoder.h, is you have to give it an what they refer to as old position. Now, old position happened to be the name they choose. You can choose anything you want. I left it as old position. And they set it to default, and I played around with this, and they set it actually to -999. And that actually works because then when you turn it on, it goes to 0, which is really, really handy. Because it actually sees the first increment and says, oh, you're supposed to be 0. And basically, that's where we're going to leave it, because the other stuff that comes in here all have to do with the LEDs and the switches, and I'm not going to do those right away, so I'm going to leave that blank until we're ready. But we are going to add more. So there's our basic setup, our basic preamble, so to speak, of our program. Now let's look at our setup. We're going to do a couple of things in here. So I'm going to change this comment here. I'm going to start the serial monitor because we probably want to be able to examine what's going on. So we're going to use the serial monitor for doing that. So we'll do our normal serial begin, and we're going to set it for 9600. We don't need to be faster than that. That's the baud rate. That'll be fine. And if you want, you can add yourself a message here, or you can leave a message out, just so you know it started. And I could just put one in here. So I'll just create one here called serial.print ln, because I want a line return at the end of it, and starting test. So there we go. So that's just our simple thing. Now we need to set up our pin modes. We said we'd have pins up there, so let's set up our pin modes. So we're going to have a pin mode, and we're going to set the first one for the, since we did them in order, I have the LED green pin, so let's do that one, LED green pin. And this is going to be set up as an output, because we are going to be sending information to it. Then we're going to have pin mode, and we're going to set up our LED red pin. I must admit, and this is probably going to jinx me now, but I'm typing much better than I did last week. And finally, we're going to have to set up a pin mode for the switch. And this one's just called switch pin. And this one is going to be an input. See, there goes my typing. That's an N. So there we go. Input. So that's our setup. That's our whole setup right there. That's all we need for this whole thing. Okay. So now we're going to move on into the main program itself. So let's do that. Let's move into our main program. We're going to do a couple of different things with it. The first thing I want to do is I don't want to worry about the switch. I'm not going to worry about the LEDs. I just want to get the encoder working. So I'm going to come down here, and I'm just going to put in at the very start, I'm going to put in here, read the encoder. That's what we're going to start with. We're going to read the encoder. And what we do with this when we're reading the encoder is basically we're going to look at the new position, and this actually here has something called long old position. Well, we should put in here a long for new position. And we're not even going to set a value to it because we don't know what it's going to be yet. But we're going to do that within our program here. So the first thing we do in here is we say our new position is equal to, and this is where I created the object called myEncoder. And I'm going to put it in as dot read, as we get that from the example file. So this is stuff that's built into the helper. This is a thing on how we read the encoder. So we're going to go ahead and read the encoder, and we're going to grab that value from the encoder. And basically it's reading it in the helper file. So now what we need to do is we need to do something if the value has changed. So we're going to have to create an if statement for this. So we start out with if new position, and we want to say not equal to. So we use not, we use the exclamation mark, not equal to old position. What we want to do is we're going to do that. We're going to put in our subroutine. We're going to create, not our subroutine, but we're going to create, what do we do if this is true? If the new position, which we're getting from the encoder, does not match the old position, and remember up here we set the old position for minus 99999. So we're going to say, hey, if it's changed, we want to do something. So the first thing we want to do is we want to say old position equals the new position. So we're going to update it. We're going to update that information, and that's really all that's doing in there. So we're going to go ahead and update it. And then, just so that we know that it's happened, we're going to go, oops, actually, let's try doing it as a serial print. That would be much better. Serial.print, and I'm going to create in here, and I'm going to say encoder equals, and then quotes, close bracket, and we're going to put in the second line, serial Println. And this is just getting the very basic going on in here. And what we want is we want the new position. We want to know what the new position was. So that's what we're looking at getting out of here. Now you can print the new position, old position. At this point, it wouldn't make any difference because we made them equal to each other. So I'm just going to say, hey, let's do that and let's print it. Now, this is a pretty short program. We're going to try this one. So first thing we're going to do is we're going to validate, make sure this is okay. See if I made any typos when I was typing it in. We'll soon find out. It's always interesting when you make typos and you have to find them. So we're going to go through here. It takes a little while to compile the first time. We've seen this before too. We're getting there. Just a little bit more green bar. Let's move. There we go. So it's done compiling. So now what I'm going to do is I'm going to go up here and just make sure I am connected. I am connected to my Arduino Uno. So I'm going to go ahead and I'm going to upload the sketch. I'm going to wait for it to upload, and then I'm going to open up the serial monitor and then get it in a position where you can see it on the screen. So this is like the most basic part of the encoder that we can make happen. So it says it's done uploading. So let me go ahead and I'll grab my serial monitor. I'm going to bring that into view for you. There it is there. We can still see most of the code. So let me just say there it says starting test, and it came up with encoder 0. Now I'm going to reach over here, and you're going to be able to see this down here, and I'm going to turn that knob clockwise, and look at that, the numbers count up, and it just keeps counting up. So it's working. And if I turn it counterclockwise, the knob, they're going down. So far so good. So we can see that we can bring in those numbers and we can count the encoder. It worked like it's supposed to. Isn't that just crazy? Right off the bat. Now I'm going to make things more interesting. And what I'm going to do is I'm going to make the lights light up. Now this is going to be a lot more involved. And I broke this down into a lot of steps. So what I'm going to do is I'm going to copy it and I'm going to put it in here because I don't want to type it all out right on one spot. Let me go into here. So right after this old position equal, actually, I copied too far. Let me try that again. And I've added lots of comments here to make life easier for you. So right after this, we're going to go in here because what I want to do is I just want to go down here and I want to put in a whole big block of information. And why did it offset like that? I hate when it does that to me. Oh, that's because it's going to offset eventually. Because there's going to be some more changes made to this program by the time we're done. So I'll just go down here and adjust it all. Being Arduino, it actually doesn't matter what the spacing is. It's just for me to follow it a little bit easier. And here we go. Let me show you what I've done. So here, that was as far as we got, right where the cursor is right now. This is as far as we got in the program, was line 33. In line 34, I want to set fade LED based on the new encoder value. So first thing I have to do is I have to set a value for fade LED. I'm going to manipulate this number. So I'm going to say that's equal to new position as well. So just like the old position, fade LED starts out as being equal to the new position. Then what I want to do is I want to map it, because my LED outputs, if you remember from pulse width modulation on the Arduino, the maximum value is 255. So what I'm going to do is I'm actually going to map this value, since I can have positive and negative numbers. I'm going to map it to plus or minus 255. So I use fade LED is equal to map, take the value fade LED, and what I'm going to do is here is for encoder value of negative 100 to encoder value 100, make it negative 255 to plus 255. So now I've mapped it to plus or minus 255 based on 0 to 100. The problem is I can turn that encoder past 100. So if I turn it to 101, this number is going to be larger than 255. If I turn it to 200, for instance, this is going to be at 512. or 510. It's just too much. It's too high for what I want. So what I'm going to do is I'm going to limit the minimum and maximum value now. So now that fade LED is now equal to 255 minus or plus 255, I'm putting in an instruction in Arduino called constrain. So I've created this constrain value, and I'm going to say, hey, constrain fade LED to a minimum of minus 255 and a maximum of plus 255. So now, no matter how far I dial this encoder, I can't go beyond 255 with this. And I can't go beyond or below negative 255. I'm going to be limited on my output to my LEDs in that amount. So the next thing I need to do is, wait a second, that's all great, fine and dandy. I've created this negative 255, but I can't put that into my pulse width modulation. It only accepts positive numbers. So we have another instruction here that's built into Arduino called ABS, which stands for absolute. So what we're going to do is we're going to take fade LED is now going to be the absolute value of fade LED. What that does, it takes the number, and whether it's negative or positive, it makes it positive. It doesn't care. So it takes the absolute value, so it turns any number into a positive number. And then what I'm going to do, just to show you how that works, I'm going to print the LED value on the screen, and we're going to do that. Now, fade LED, I didn't set it up yet, so I need to add that to my list of tags. Since these are in long, which means they have an extra long set of bits, I'm going to also have to create this one in long because it's going to be talking to it. So way up here, there it is. I'm going to create long, and it's just going to be fade LED. That's our tag. So now I can come down here and I'm going to go, okay, let's validate this. It's going to compile the sketch. Let's see if it has any errors. And it's done compiling and there were no errors. So let's go and load this up and see what it looks like. Let's see what happens. So we're going to go ahead and compile that, and then it's going to upload into the board, and we're going to check this out and see what's happening in here. So it's done there. Let's open this up, and we can see right now it's there. In fact, I can clear this output. I can just start fresh. And what I'm going to do is I'm going to turn these. Oh, I didn't change the other part there, but there's my encoder value. There's my scaled value. So you can see as I go up, I want to go, and let's say 100 is my maximum. So let's scroll up, and I'm going to go slow so we can get to 100. There we are. At 100 on the encoder, I get an LED value for 255. If I go beyond 100, I'm at 108. My value for the LED is still 255. So now I've limited it and constrained it. I've mapped it and constrained it to 255 as my maximum. So now let's very quickly bring this back down, and we're going to go down past 0. Okay, so now we're going into negative, but my LED values are still positive. And that was accomplished by using that ABS command. This one over here on the left, we use ABS, and what that does is that takes the absolute value of fade LED and makes it positive. So we maintain that positive number. And again, as I turn that down, I can see I can bring that up, and it'll go back up to full brightness again. Up to minus 255, which is plus 255. And if I scroll past, it doesn't care. So that all works. So let's go back down to 0 for a moment. So that's going to play part in the next part of this. And there we go. There's 0. So now that works. Woo! We actually made that happen. And I'm going to fix up my printing here because I want to get rid of Println. Because when this prints, I want it to be normal. And this one here, I actually have a blank line in here at the end, so this will be fine. It'll now put the LED value and the encoder value on the same line. Because it'll print this, it doesn't advance to the new line, it then prints all of this. So it'll look nicer on the serial monitor. So that's what we're after there. So now let's look at the next block of our code. The next block of our code is actually going to turn on the LED itself. So, what do I need in here? I need, I think, all of this. We're soon going to find out. Because this is a new if statement. So we're just going to move down here and we're going to do this. So now, based on what those values are, what we're going to do is we're going to take that fade LED value, plus or minus. And what we're going to look at is we're going to look at new position. Because if new position is greater than -1, in other words, from 0 to 255, we are going to make the green LED pin light up, and we're going to turn the red LED pin and set it to 0 so it's off. So that's what we're doing there. Now, if the number is negative, so if it's the opposite of this, the else, we're going to make the green pin turn off, and we're going to turn the red pin on and have it increase and decrease in brightness. So if this works, I don't think we have any new values. So let's just go ahead. I'm going to try and just an upload. See if it's happy. I think it'll be okay. We'll soon find out. And we're going to upload it. It's done uploading. Let me open up my serial monitor again. We can see starting test encoder value. I gotta bring that back in just a little bit so you can see it. We can now see that's all on one line. In fact, I'll move it over just a touch more because we know these numbers are going to get a little bigger. So let's start bringing this up. And as we bring this up, we should be able to see this green LED there just lit up. It's faint, but it's there. And look at that. As I turn it, it's getting brighter and brighter. And we can turn that all the way up until it's up to 255. Right there. And if I shadow that, you can see that LED is on, and that's at full brightness. So it is up to full brightness. So let's come down here. And we're going to dial this down. And now we've gone into the negative numbers. And if I shadow that, you might be able to tell. In fact, I might have to... Let me bring that closer to 0. You can see the red LED comes on and off now. So as we go into the negatives, and again, we can bring that all the way up, and I can take that all the way up to the full brightness and make that bright red. So now I've done this. I've actually managed to make the adjustment that I can go either the green or the red. Now you might be saying, well, where is this useful to me? Well, it doesn't have to be lights. If it's in your model trains, this doesn't have to be light. If you're trying to supply DC power to a motor, this could be forward and reverse and adjustable speed. So we've actually given you the ability to have adjustable speeds in here, which is really kind of nice. It's a nice little feature, and it just adds to the credibility of whatever you're running. So now I can actually bring from a stop, I can make a motor go forward, and then I can stop it, and I can then make a motor go backwards. This is a basic throttle control. If you add a transistor and the actual motor circuit on the outside to vary the voltage instead of just varying a light, you could use it to vary the voltage to a train track. You can now run a train. Why is this handy? Because you could have it set up on your model train layout. Maybe you've got a conveyor that is traveling to haul ore on your mill. You could actually fine-tune the speed of it, and you can actually control it from here, make an adjustment with it, and then later on, if you decide it's too slow or too fast, you just turn your encoder a bit and change it. If you want it to run the other direction, you can do that too. So now you have some manipulation that you can do, and you can start controlling things with small electronics like this. So it actually gives you some capabilities. I mentioned one more feature that was available on this particular encoder, and that is the fact that it has a switch on it. So let's do the full-blown program now. So to do the full-blown program, what I'm going to do is I'm going to include another whole big part, and I'm just going to copy and paste it in because it's going to take too long to do it. And I'm going to come back up here to my main loop. I'm going to come down here, create an empty space, and I'm going to paste it in. And what I've done here is I'm going to read the state of the switch. And now I'm going to look at switch state is equal to digital read the switch pin. So I'm going to look at the switch pin. The switch pin is just by pressing the knob. And I'm going to toggle between on and off for each press of the switch. So if not state, switch state, so basically I'm going to look for it to be 0. This has got high going in all the time, and we'll show how that sets up. In fact, actually switch pin, I created as an input. We actually want to create it as an input pull up. That'll put 5 volts to the switch at all times, and every time we press it, it's going to go to ground. So it's going to go to 0. So that's what we've done here. And then what's going to happen is here, when it's pressed, toggle on, off is going to equal not toggle on and off. So in other words, it's going to toggle between on and off. True and false. That's what we're looking for with the toggle on and off. We're just looking for true and false. And then we're going to come down here and it's going to say switch pressed on, switch pressed off, depending on whether it's true or false. And then down here we have a delay. Now the delay is if I don't put that in when I press the button, what happens is you'll read the button multiple times. So I'm creating a slight delay to give me time to let go of the button. So I need to add a couple more variables up here which aren't on here right now. So let me go ahead and add the 2 variables we need. And there's only 2. So here's the variables here. I created 2 Boolean logical states. Switch state and toggle on and off between, and I just set them to false to start with. So I start with those, and I'm going to do this. And right now, all that's going to happen is I'm going to send out a message. I'm not doing anything with the on and off, and I'll show you as the last part to do that. So let's upload this. And we'll look at it on the serial monitor. This is how I would build my program. I build it in little blocks until I'm happy. So it says it's uploading it. It's done uploading. Here's my page. It says starting test, encoders at 0. Just to prove that, we can turn the encoder. There we go. And the green light is on. Now, if I press this little button, see I held it too long there. Switch pressed on, switch pressed off, switch pressed on, switch pressed off. So I'm seeing switch pressed tells me that I have an input change. That's the state. And then the toggle on off is that set to true or is it set to false? So each time it goes through that little bit of a loop, it toggles from on to off or from off to on. So it works. It actually works. We're actually able to get that input. So now the same device is not only giving me encoder values, but it's giving me a momentary push button. Now let's utilize it and make more sense out of it. This is the last change to my program. So what I'm going to do here is let me go grab the part here that I need. And this is going to be a pretty simple change to what we have here. And what I have is I only want the encoder to work if it's in the on position. So I'm going to come down here before the encoder, where I read the encoder, and I'm going to paste in complete when on. So if toggle on off is true, then go ahead and set all this. And because of that, I'm going to need a brace down here at the bottom. But I'm going to add one more feature. When I turn it off, I should be really turning off my LEDs if I'm not going to do it. So we'll copy, and I'm going to come down here. And if I paste it in there, it should be in there. And I'm just going to click here. If I do that, it's toggle on off. It tells me on here that that's where my other end of my brace is. This one here shows me that it's right here. And if I go to this one here, that's my main loop. So I hopefully am in the right spot. And here I'm just setting both pins to 0 for the lights. Let's see what this does. I'm going to upload this. Now, I would move things around just a little bit. My completed version is all nice and neat. This one, I get out of alignment a little bit up ahead here, but that's okay. So it's done uploading, so now let's look at what's going on. First of all, If you notice this time under starting test, it didn't give me an encoder value because by default, it's off. So if I press this to on, I now get a decoder value. As I turn this up, there's my green. We'll go the other way. There's my red. Now if I press the button, my LEDs turn off. So I can stop it immediately by pressing the button. When I press it again, it comes back on to where I left off. So wherever the dial was turned to last. So it does give me the opportunity to change my settings. I'll just prove that. I'll go up to green. I'll press the button. The light went out. Press the button again. The light comes back on. So now with this simple little device, I've created something that I can control going forward, going up, coming down in values, turning on and off LEDs in this case, and I can actually turn on and off the whole system by using the button in the center. So I've utilized all the pieces that are available in this particular encoder. There's lots of these encoders available. Remember I said this one had 2 of the resistors on the back. If I bring this up here, and in fact actually rotate it that way, you'll see it even says 10K on the back. That should be pretty close to the focus part of the lens. And there's 2 resistors in there marked R2 and R3. R1 doesn't have a resistor across it, and that's fine because that's for the push button. We don't need one of those. So this works. So this is all working, and it does it now. So we're able to use the encoder to count up, count down, and we're also able to use the switch to turn it all on or all off. So we have a lot of variables that we can do with this thing. So now if you want to control that model route, that train, that regular DC train, you can, or that regular DC motor, you can now control it through this and just add on a transistor on the other sides. Or an H bridge, you could feed it and there's your 2 power leads. The 2 leads that it needs are the 2 leads going to the LED. So now you have some flexibility. You can start utilizing this and come up with ideas on what you want to run. So we have some availability to us. Works really well. Let's go look at the CircuitPython version of this now. So what I'm going to do is I'm going to change screens here. I'm going to pull up my other program. Let me move this one out of the way. Let me bring this one in. This one in is the CircuitPython. This is a Feather M4. I should be able to zoom in one more with this one because it's a little bit smaller physically. It is. Look at that. I have my board over here with my encoder. I have a knob on it just like before. And in fact, actually, you can see my red LED is getting dimmer up in the top left. And as I cross over, it goes to green. If I press the button, oh, I held it twice. There, the light went out. Press it once, light comes back on. So this actually works identical to the Arduino version, but it's programmed a little differently. So let's look at the drawing for this one first before we get into the rest of it. So we'll just come up here. Let me move over to the other drawing. Again, this is the pre-built board. This has the resistors on it, so that's kind of the encoder that I'm using. It's all pre-wired. Here's the rest of it here. So I have my 2 LEDs. They're connected to pins 5 and 6. My switch is connected to pin 9, and 10 and 11 are connected to the A and B spots on the encoder. So that's everything I need there. So it's pretty much the same circuit, except this one's running on 3.3 volts instead of running on 5 volts like it was in Arduino. The code is here. So let's have a look and let's go through this code. So I have my title at the top, the base encoder. I'm going to import all my helper files. For this one, I bring in the board, which gives me my ID pins. This lets me know what pins I'm using. Time is for any delays that I want to add or timing features. Rotary I/O tells me how to use an encoder. So this is my helper file for my encoder. Digital I/O allows me to use the push button. Pulse I/O allows me to do the pulse width modulation out for the lights. Simple I/O and math work together to be able to do the calculations, to do the mapping and things like that I did before. So now let's go through and see what we have here. So it says create an object. So just like before, we have to create an object for the encoder. This one I'm going to call encoder is equal to rotary I/O. That was that import file up here. rotary I/O, incremental encoder, which is what this is. It goes one step at a time. And it's connected to pins, boards D11 and D10. And its last position, just like the other one, I had to give it a position, starting position. This one is considered to be none. I don't know where we are. It's none. This is what they use in this helper file. This is the way it's done. Then what we're going to do is we're going to create our assignments for our switches, our switch and our LEDs. So I have here switch encoder. So this is the switch that's built onto the encoder. And I'm going to set it to pin 9, and then I'm going to set it as an input. And that's all I'm doing is setting the direction. So this is standard CircuitPython stuff. And I also want it to be a pull-up, so I create the pull-up feature to it. Just like I had to in the other one, I just used the input pull-up. So the first 3 lines are for the switch. What's really nice is the next 2 lines, there's only 1 line for each. Because what I'm doing is I'm using the pulse I/O instead of the digital I/O. I'm using it for pulse width modulations to pin 5 and 6. And I'm just setting them up as PWM, pulse width modulation out. So that's a simple set. LED green and LED red. Set them up for the outputs as pulse width modulation. And that's done. That's our setup. And I had to create 1 variable up here that I needed that I couldn't create down in the program. So toggle on off is set to false, just like we had for the before for the push button. When we set it, we either pulse it, change it from on to off or off to on. And here's our program. So that was everything up top. That was really short. The main program, just like before, we're going to read the state of the switch. We're going to do everything in the exact same order. We just did it in Arduino. So if not switch encoder dot value, what we're going to do is toggle on off equals not toggle on off. And so we used not equals, where we use the exclamation equals. This time we just, in fact, actually we just put the exclamation in front of toggle on off. This used the word not for the keyword, not the exclamation mark like you did in Arduino. And then we're going to say if on off, in other words, if it's true, switch pressed on. Otherwise, switch pressed off. We can open our serial monitor down here at the beginning, at the bottom. I'm going to increase that slightly. If I push the button, it's off. If I push the button, it's on. So I get that message comes through that print statement. And here I created a slight delay. This is again 250 milliseconds, same as I did in the other one. Because if I hold the button, I'll show you if I hold the button, it goes on and off all the time by itself. And we don't want to do that. We actually, it gives us time to let go of the button. So we don't have to be there forever holding on to it. Okay, then what we do is if it's true, in other words, if it's on, we're going to look at the position of the encoder. We're going to look at the last position. If the last position is none, or the last position is not, the position is not the last position, in other words, they're not the same, I want to set the last position is equal to position. Fade LED is equal to last position. Now, unlike the other one where I could use fade LED all the way through, I can't do this time. Because what happens here is fade LED is going to equal to last position. Well, last position is a big number. And it's actually a floating point number. So it's going to create a floating point item. So I have to go map fade is equal to simple IO. This is where I use that simple IO extension for map range. And let me just see, I'm going to go here. And what I've done in this one is I've actually created my range. Instead of 100 and 255, I've gone to 50 and 32,767, which is just much larger. That's a signed bit. And actually, I think I probably should have gone to 65, but I'm doing it this way just because it works, and it's fine for what we're doing. So I've created that mapping range just like I did before. So I had to do that in order to convert a small number from the encoder to a large value by pulse width modulation. Unlike the Arduino that only goes from 0 to 255 for the output on pulse width, this goes much, much higher. It's a much higher resolution. So it's a much bigger number. Once we do that, we have a problem here. And what we need to do is we need to take this and we may need to make that number positive. So we're going to go in here and we're going to go set LED equals math dot. And this is FABS. The other one in Arduino was called ABS for absolute. This is FABS for floating absolute. So it does only floating point numbers. So this is why I was saying we want an integer when we eventually put it out to the light. But for now, this is going to be a floating point number. So what we do is we want to take this range that we've created and make it positive. We want to make sure it's a positive number. Then what we're going to do, so this is get the absolute value of map fade. And then what we do is we change the number back to an integer. So since it became a floating point, I need to bring it back to an integer because I don't want decimal points sending out, trying to set out on my pulse width modulation. So I use an instruction called truncate. And basically what it says here is fade LED is equal to the math dot truncate set LED. And basically what that does is it takes it and rounds off any decimal points. So if it's 0.2, it goes down to 0. If it's 0.7, it goes up to 1. So what it does, it varies that last number up or down one number depending on where it needs to round off. So that's what my truncate does. And then what I've done here is the exact same thing as before. If my fade LED is greater than 32,767, make it equal to 32,767. So this is my, I don't have a constrain instruction like we do in Arduino. So instead of constrain, I've set an upper limit. So this is my upper limit. And then what I've done here is because I don't have to worry about the negative 32,767 because I'm using the absolute value. So what I'm saying is, hey, if this number is bigger than 32,767, just make it that. The lowest it can get is 0. So I'm okay with the constraint. I don't have to, I constrained it before I did the absolute. This time I do the absolute, and then I set my constraining on it afterwards. Just a slightly different way of doing it. This one is print the values. So basically I just print the position and print the LED value, and I let it sleep for a moment so that it doesn't give me any errors. And it says here, if last position is positive, set value for green LED. So this is the same as before. If the last position is greater than -1, then turn on the green LED. If it's otherwise, turn on the red LED. And that's what it does. And if you're completely off, turn off the lights. So what happens here is as I turn these numbers, you can see my numbers are increasing. So if I increase my rotary encoder to higher than 50, so when I get up here to 50, I'm at 32,767, which is what my mapping was set for, my range. Now if I go beyond, we can see that my encoder has gone higher, but I'm still maximum output of 32,767. And again, I'm going to bring this down. So that's my green LED is on in the top left corner. Let me bring this down all the way. That's a lot of turns. But I'm going to bring it down here to 0. And I'm going to go negative now. And we can see with negative, my LED values are still positive, except my red LED is lit up. So it's changed now to the red LED. Okay, I'm at partway lit up. I'm going to press the button. I turned it off. Both LEDs are off. If I press it again, it comes back on where it left off. So it all works. So that's basically it. That's how we can use an encoder to create a variable input. Now you're thinking, well, I don't necessarily want to control a motor. You could use it for selecting and scrolling up and down a list of a menu. So if you've created a menu of things that you want it to do and you're doing it with a display, you could scroll through it, and when you get to the one you want, you press the button to say accept it. And then you go into whatever that menu is. So you could have it for setting different devices. You could have it, if model train control, I know Walter has a day-night vision on his layout. You could dial it to night, click the button, and now let it go through and change to the night cycle. When you're ready, you could dial it to the day, click the button, and go to day cycle. The nice thing is you could use that, go to manual, and now what you can do is you can manually adjust between day and night so you can get evening or dawn. You could program all those things into your lighting system. By using this encoder, you have lots of flexibility. So it's more flexible than a switch. It's more flexible than just a bunch of push buttons. it actually gives you a variable that you can play with and adjust. Pardon me while I clear my throat there, but I hope that was interesting to you. I think encoders can be used. You just have to look at the right application. They're not the answer for everything, just like everything in electronics. There's multiple answers on how to do anything. So what I would suggest is get out there, play with them, see what you can do with them. Use the basic helper files to start. You can create it. I talked about earlier that you're actually getting 4 different signals in from the AB pin combination. That's why they call it a quadrant encoder or an incremental encoder. And you just want to be able to take your time and work your way through it. And if you want to create your own code for that, you're certainly welcome to do it. You can create your own code based on those 2 pins. You can also use the simple helper files, and it saves you probably 30-40 rungs of code that you would have to type in yourself. So that's everything I've got for you for today. I hope you've enjoyed it. This was Encoder Inputs with CircuitPython and Arduino. Thank you, Walter, for that comment. I hope it has been relevant for you. So in closing, this was episode 22, Microcontrollers with kingernorth. Thank you very much. If you want, follow me on Twitter at kingernorth. That way, when I'm ready to do these shows, I will send out information and I will tweet about it. And you can also, of course, just check on the YouTube channel for other videos that are related at youtube.com/kingernorth. Hope everybody's had a good time. Hope you actually had a chance to learn something and you had a little bit of interest in it. And until next time, stay safe and keep working on things out there and trying it. Goodbye, everyone.